Hello, we're Team 25. My name's Gabrielle, and I'm here with Mara, Danielle, Andrew, and Alexander. And today we're going to present an analysis and redesign of a toaster. So first, we're going to give a quick product description. So a toaster is a user-friendly and simple kitchen appliance which users use to lightly cook and toast bread slices. Here is an assembled position of our toaster that we are redesigning. And on the right is an exploded view of that toaster, labeling the 16 different components of said toaster. Now we're going to touch on our customer base. And first we're going to look at our primary customers. So our primary customers are going to be typically a household family, which is including parental figures and children. So this original design is going to target a small group of users who only need to toast 1 to 2 pieces of bread at a time. Therefore, time is not of the essence to complete said task. We want this design to be user-friendly and also appealing to the eye as it's going to sit in the kitchen counter of a home. Our secondary customers are going to be users in the hotel and restaurant industry, where time and quantity is of the utmost importance. Therefore, this variant has to be able to complete the task at a faster rate when compared to our original design.
Okay, so for our functional analysis diagram, we identified 2 primary basic functions, which were add heat and contain bread. And we identified 4 supporting functions, which were assure dependability and convenience, please the senses, and enhance the product.
And for the assembly sequence, this is a diagram for assembly sequence 1. Assembly sequence 1 delays putting on the outer shell, which can be colored in different ways for consumer needs. And it has 2 sub-assemblies. There's a control assembly that moves the bread, and the right internal assembly, which holds the bread. And this is assembly sequence 2. And the main difference with assembly sequence 2 is it will delay the insertion of the electrical card, so you can add different powers. And it has 2 sub-assemblies, the external assembly, which has the toaster frame, and then the control assembly on the right without the electrical card inserted. And the main differences between those is primarily it's going to be the assembly. It's very easy to assemble assembly 2. Assembly 1 is more difficult, but assembly 1 is a little bit easier to retest. But looking at the diagram, assembly sequence 2 is the better choice.
After that, we did a function component mapping matrix. And to do this, we put our part names on the left side, and then above we have our sub functions, which are control temperature, transfer energy to internal panels, isolate bread, maintain position, eject bread safely, and insulate cooking process. And by doing this, we were able to identify the product platform from which product variants could be derived.
This is our bill of materials. We have a total cost for each individual part. This is based off assembly sequence 2. We realized that our total is a little bit less than we think it should be. So we're assuming that we might have underguessed the amount of assembly costs that it would take. Here's our quad chart to help decide which parts are best candidates for elimination or redesign with DfM.
This is the functional differentiation table. So we wanted to split up different functions from the FAST diagram for the primary and secondary customer groups. And we determined that the different functions for the customer groups would be performance of toasting the bread in a timely manner and the way that the toaster facilitates storage. This is the component commonality table, and we determined that the outer casing and heating components would have to be different for the 2 different toasters for the 2 different groups. And these are the CADs for the final assembly. So just going through it, here's the top covers, the back internal cover, the back covers, front internal cover, and here's the interface between the modules and the platforms with the release button, the front cover, and the temperature button in the front cover, the heating plates and internal covers, the electrical card and the front cover, the ejection bar, and the internal panels.
So using the better of the 2 assemblies we went through earlier, a product family assembly diagram was created. We originally started off with a collecting tray. This would be different sizes for the industrial toaster versus the residential toaster. Because of this, there isn't any delayed product differentiation. Another issue with the original assembly sequence is that there are 3 separate steps to add additional components when producing an industrial toaster versus a residential one. After implementing delayed differentiation, the toasters are able to be assembled simpler. The internal components are assembled first with the delayed addition of internal parts for the industrial toaster. Producing toasters this way reduces the number of times additional components are added. Thank you so much for listening.